First reaction we learned. We can either use heat or UV light. We make methyl chloride plus HCl. It happens for this particular process by a series of first one initiation step, then two propagation steps. Let's imagine for a minute that we did this reaction with 100 molecules of methane plus 100 molecules of chlorine. You could imagine then that we would make 100 molecules of CH3Cl plus 100 molecules of HCl. Let's just imagine that. I don't like 1 to 1 and 2 to 2. I like bigger numbers, right? What I want us to do now is I want us to imagine a different case. This is the one we did. Instead, let's imagine what happens if we have 100 molecules of methane and 200 molecules of Cl2. This is the case we're going to imagine now. We have a lot more chlorine floating around. Okay? We start off the reaction with an initiation step. I'm not going to rewrite it now, but on an exam, you should be prepared to rewrite this initiation step. Propagation steps, I'll re-practice these right now with you. So let's just take this chlorine radical that came from an initiation step. And let's take methane. Again, we are going to re-practice what we just did on the notes previously. That's how important it is. These two things find one another. We make HCl. We make our methyl radical. Our methyl radical goes on to the second line of the propagation step. It reacts with Cl2. We'll talk about those energetics in tomorrow's class, or maybe later today. We make our product molecule, methyl chloride, and we make Cl radical. I went pretty fast writing this, just try to catch up. I'll just talk and narrate a little bit about what's happening here. But this is the first step we have happen. Chlorine radical then goes out hunting for another methane molecule. And in this reaction, there's lots of them. So chlorine goes out, finds another methyl molecule, makes another methyl radical, makes another molecule of methyl chloride. And this process keeps happening over and over and over again until we run out of Cl2. When we run out of Cl2, this reaction stops and we can't keep going anymore. Let's imagine, though, now that we have lots of extra chlorine floating around. So after some time, CH4 goes down and CH3Cl is increasing in concentration. Let's actually put brackets around methane. Brackets around methyl chloride. So it literally means the concentration of methane is going down. The concentration of methyl chloride is going up. Let's just imagine. We start making more and more of this. And imagine if we pumped a little more chlorine into the reaction. So, after some time, we start running out of methane. And we start making more and more of this, and we have lots of chlorine floating around. At some point, chlorine radical is not going to have any methane to find anymore, and instead, it's going to find a molecule of methyl chloride. So let's just imagine the case that we have lots of chlorine. This reaction starts running. The amount of methane is going down. We still have a lot of chlorine. The amount of methyl chloride is going up. At some point, we run out of methane. And we have lots of this floating around, and we have lots of leftover chlorine. At this point in time, Chlorine radical still wants electrons, and it's going to take them from the same place it took them before, carbon-hydrogen bond. And I want you to draw the result of when chlorine radical finds a carbon-hydrogen bond in methyl chloride. It wants an electron. I gave it one electron. I broke this bond. Hydrogen is going with it. I'm pushing this electron back to carbon because these bonds are breaking homolytically, because this wants one. You give it one, leaves one behind. I want you to draw the two things that this arrow describes, or these two arrows describe, in the boxes right here. Try and push yourself right now. You know, it's the morning, probably sitting at home in pajamas drinking coffee. Wish I was. Not in your home, in my home, drinking coffee in pajamas. But fill this in right now. This is a good moment for you to test yourself. Are you following along what's happening in lecture? Okay? Should be drawing two products here. One of them will be a radical. One of them will be a fully covalent, happy compound. Part of it will be very simple. The HCl. That's what happens when this one electron breaks this bond, goes to chlorine, we form a new bond. The other thing that's left behind is this new radical. It's like a methyl radical, but it already has a chlorine on it. It already has a chlorine on it because chlorine radical found this molecule, and it's going after the hydrogen-carbon bond. There's energetic reasons for this. We're not going to worry our pretty little heads over them today or tomorrow or ever, but we're just going to follow this logical process that chlorine radical is hunting for carbon-hydrogen bonds. Carbon radicals are going to be hunting for chlorine bonds. Let's take this new propagation step. Notice we've entered a new propagation step. This is a new molecule. Reacts first with chlorine, makes a new radical. This new radical finds a molecule of Cl2, of which there was a great abundance in this reaction, double what we normally use. It finds chlorine, that's the best one choice for it, and the result of this particular reaction is that we make dichloromethane, and we regenerate a chlorine radical. So in this step, we've made CH2, Cl2, plus regenerated. And the chlorine radical can go back and keep hunting for more molecules of, I'm going to move this just a little bit here. Two propagation steps we're worried about are these two right here, between my hands. Again, this whole process we're exploring what happens if a chlorine radical doesn't find methane, but instead finds methyl chloride. Finds methyl chloride, reacts very similar to what we did before, makes a new radical. This new radical finds Cl2, and we've now dichlorinated our methane molecule and regenerated a Cl2 radical. So this process can keep going. It'll start consuming all the methyl chloride until it makes dichloromethane here. This could keep going at great length. I want you on your own to imagine even more Cl2. You're going to practice this work on your own. We can talk about it in office hours, but I'm not going to teach it in class. This is kind of a on your own type problem after you've studied the notes up into this point. I want you to take CH2Cl2, and with chlorine, I want you to work your way towards CHCl3. And then finally, CCl4 through a series of multiple propagation steps. Just keep imagining that we never run out of chlorine, that we can just keep going over and over and over again. This series of events is called a consecutive, or it's called consecutive reactions. And I've gone a little bit over time here where I wanted to take a break. So it's about 10:11. We're going to resume at about 10:20, about a 9-minute break. And